And good morning, classmates. Good morning, Philippines. Good morning, world. We are Group 1 and we are about to report flotation. So flotation. So when we hear the word flotation, it's easier to digest the word when we chop it. So we have the word float. Float. So when something is floating, it is on top or on top of a fluid. For example, air or water. So yeah. Then chemical engineering, flotation is any operation that involves one solid being separated from another by floating one of them at or on the surface of a fluid. Here, it's called flotation. So, from the word itself, flotation, we can separate solid from the fluid by floating it so that we can achieve that separation. So various flotation processes depend upon the successful application of a number of physical principles, three of which are film suspension, oil buoyancy, and bubble levitation. So in film suspension, for example, we have this particle being floated in this fluid. So, film suspension is caused by surface tension of the fluid. So, since surface tension is higher, since surface tension is high, the coherence of the molecules of the fluid is strong, making it elastic, so that when bubbles or the particles being floated above will result in, so that they will aggregate more or compress more because of this elastic film here. So that is film suspension. Next, oil buoyancy. Since particles are being conditioned using reagents, which will be discussed later. Oil buoyancy, since oil is denser, is lighter than water. It will rise to the surface of the pulp and carry with it any mineral particle that have become immersed in it. So next, yung bubble levitation naman, this depends upon the aid of the bubbles of the gas, which by attaching themselves to particles of minerals, buoy them to the minerals. So in bubble levitation, for example, this is the particle, and this is the solid, this is the bubble. Bubble levitation, tendency of the bubbles to make the particles levitate. Against. So this is the bubbles, the particle. So the tendency of the bubble to make the particle levitate. So it will be discussed more later. So here are some of the applications of flotation. So we have in the mineral industry, ore processing, and we have in wastewater treatment when we treat water so that yung mga impurities can be separated.
We've been introduced to flotation process and some of its applications. Let's now discuss basic steps in flotation. Basically, flotation has two basic steps, the conditioning and the separation. So what happens with these two steps? First, the feed, which is a slurry or mixture of particles that are to be separated, that with particle sizes adjusted properly, are being fed to the conditioning unit. This conditioning unit, reagents are added in this conditioning unit. So the main purpose of this conditioning step is to create physical chemical condition for achieving appropriate selectivity for the particles to be separated. So the next step is separation. So basically, this is when the separation happens. Reagents are also added and air is introduced. In this step, air is introduced and air bubbles are generated. So the particles to be separated, attached to the bubbles formed and they float or levitate on the top and are removed as froth. Yung froth, just a term yung air bubbles on top of a liquid, like those you can see in beers and soft drinks, the white portion on top. Yeah. The overflow, the froth overflow is termed as concentrate, while the underflow or the remains that remains in the solution is the slurry or tailings. So we've said that in flotation, we introduce our reagents that aid in the flotation process. So what are these reagents? So it can be classified into three: collectors, modifiers, and frothers. So what are these three? Collectors, fairly large group of organic chemical compounds. Basic purpose is to selectively form a hydrophobic layer on a given mineral surface in the flotation pulp and thus provide conditions for attachment of hydrophobic particles to air bubbles and recovery of such particles in the froth. So basically, collectors are used to coat the mineral surfaces, making them hydrophobic. So, ma-separate sila sa hydrophilic particles or those that go in the water. Next. The second one are frothers. Frothers are interpolar surface-active compounds that lower the surface tension of water and have the ability to absorb on the air bubble water in the phase. Their presence in the liquid phase increases the field strength of the air bubbles, thus providing better attachment of hydrophobic particles to the bubble. So basically, frothers, they stabilize the air bubbles and to make the effective particle bubble attachment and also aid in the removal of the recovery of the froth. Next is modifiers. So modifiers, these can be classified as activators, suppressants, pH regulators, dispersants, and flocculants. The main purpose is to modify the action of the collector and mineral surfaces, and as a consequence, govern the selectivity of the flotation process. First class of modifier activator. So these are used to make a mineral surface amenable to collector doping. So the next one is pH regulator. So yeah, basically the purpose of this pH regulator is to adjust or control the pH of the feed, so which is very critical in the flotation process. Next is depressant. Depressant assist in selectivity or stop unwanted minerals from floating. The last were dispersants and flocculants. They control the interference and the increase in reagents consumption. So further description of this flotation reagents will be discussed.
Good morning, everyone. I'm Ian. So I'm going to discuss the mechanism on how to use those reagents and how they react with your minerals or liquids. So there are definitions there, but I will show you in a more simpler way how that happens through illustration. Chief, I can carry. So consider this as your particle, and you want to separate that from the surrounding liquid. So the process of separation of a particle like this from a fluid can be done using adsorption of bubbles. So in simple thinking, we attach the bubble to the particle and it floats. But it's not that simple. So we have to use the properties that many reagents introduce. First, there are flocculants. Flocculants aid in what? So they, anyone familiar with the term? So flocculants tend to allow particles to aggregate. So of course, when you are going to separate something, you want it to be as tight as possible. So you want to clump them together so that separation will be easier. So the flocculants will allow particles to stick with each other into larger particles so that again recovery will be higher. Next, you have the modifying agents. So as discussed earlier, modifying agents can alter your pH, render selectivity to the collectors, and non-selectivity or depress to the depressing factor. So, modifying agents will be introduced into your fluid. So they will attach here on the surface, and this will allow for selectivity. Ibig sabihin, if you have collectors here, of course there are other particles present here. If you want to isolate only this, you'll have to put modifying agents that will allow selectivity of your collector to attach to only these particles and not to this next particle. So that's the role of your modifying agents. They will allow the attachment of your collectors and the selectivity of your collectors to your desired particles. So there, we introduce modifiers. Next, we will introduce your collectors. The collectors are basically large molecules with a hydrophobic end and a polar end. Polar end orients itself to the surface, while the hydrophobic end orients itself to the outside. We call our concept on mycels during ChE, Chem 40. Yes. So those molecules, those large molecules, will surround modifiers and will orient the hydrophobic tails outside. The hydrophobic tails will in a way make your particle hydrophobic. So why is that important? Imagine